Hi, everybody. My name is John Samankowitz. I'm with Beer Law Center. I've got just a couple of seconds today to tell you a little bit about us. We're one of the sponsors and speakers here at the virtual conference. We're a small law firm based in Raleigh, North Carolina, and we have devoted our practice to alcohol producers and sellers, breweries, wineries, meaderies, cideries, kombucha, you name it, we've worked on it before. If you have a question, give us a call. We don't charge for an initial consult, and if we don't have the answer, we'll help you find somebody who does. You can reach us at 919-335-5291. It's a telephone number. If you don't like that, just drop me an email at john@beerlawcenter.com, john@beerlawcenter.com, or find us on social media at Beer Law Center. We'd love to hear from you and we'll help you grow your business. Have a great day.
Good afternoon and welcome. Today we'll be discussing how to transition from purchased CO2 dependence to CO2 independence. I am John Kiedrowski, Managing Director of Dalum Beverage Equipment USA, which is located in Algoma, Wisconsin. I worked at Miller Brewing Company for 32 years in both plant operations and engineering, and I retired some years ago as the Director of Process Design at Miller. Now I will ask the other three presenters to please introduce themselves.
Hey, sorry about the interruption, John. Eric Dean, Sales Manager, Dalum USA, and I'm located right here in Algoma, Wisconsin.
Good afternoon. I'm Lenzie Kinyon. I'm retired also, but still back in the business. I started brewing 50-some years ago in 1971. Worked in big breweries, small breweries, craft breweries, worked for a brewing engineering company, and even taught a couple of classes at a local community college. And I live here in North Carolina.
Well, hello. My name is Jan. I'm a former long-term brewmaster of the Danish brewery Svanike Bryghus on the island of Bornholm. And now I've gone solo with my own consultancy business. I do all kinds, microbiology over plant design, whatever it could be for craft breweries. And I'm based in Georgia, Caucasus right now, but also in Denmark.
Next slide. Okay, for the agenda, I will be presenting the traditional way to collect CO2. That is how it is done virtually at all large breweries. I will not get into the difference or details of how the Dalum system works or how any of our competitors' systems work. You can best gather that information by talking directly to your suppliers. Eric has quoted systems to over 100 craft breweries over the last 12 months, and he has a very good idea of the questions they ask and the obstacles they face. He will explain the steps and discuss with you what you will need to take as you investigate going forward with CO2 collection in your brewery. Lenzie will explain and discuss how successful collection is carried out and fine-tuned in a brewery. Jan installed and operated the first Dalum collection unit, and he will share that experience with you. This is a typical flow diagram for a system you would find in any large brewery. Gas enters what we call a scrubber. Gas from the fermenters enters into a scrubber. And where there's water is coming down through a media and the gas is going up and out. And during this process, we are eliminating aromas that come from the fermentation materials inside the fermenter. The gas then goes to a compressor, usually two-stage compressor, which takes it up to about 240 PSI, which I believe is 15 bar. After the compressor, we go through a desiccant dryer system, which basically lowers the dew point of the gas so that the moisture does not freeze in the liquefaction system. After that, we're going to go through activated carbon filters, and the carbon takes out the sulfites that come from the yeast when the yeast reacts with the water and the malt in the brewing process. From the carbon purifiers, the gas, now at 240 PSI, goes up into a condenser where it meets up with a surface that is cold and it starts to form droplets of liquid CO2. You can compare this very easily to basically if you take on a warm, humid day, if you take a cold beer out of the refrigerator, it'll immediately start to condense droplets on the outside of the bottle. That's exactly what's happening inside the condenser. The CO2 is going from gaseous stage to a liquid stage, and basically the droplets are clear and it looks just like water. From there, we go into a storage tank as a liquid. And then when it's ready to use the gas, when you're ready to use the gas, it goes out through a vaporizer. The vaporizer basically adds heat to the gas, to the liquid, and it turns back into a gaseous form of CO2. This is a simple phase diagram just showing how the pressure and temperatures work how we go from a gas to a liquid stage. On the left side, you can see that the compressors are acting at about 240 psi in a traditional system. And then on the right, on the bottom chart, you can see that we're going to minus 17 F in temperature. And at that point, the gas will condense into a liquid. Now you can, going up and down the curve, you can go, if you want to go to a higher pressure, that means you can condense at a lower temperature. Or if you compress to a lower pressure, then you need a lower temperature. To get the temperature, most of the large breweries are using ammonia systems, which is really not applicable to a craft brewery, which normally would be using a Freon type system to do this. Go ahead. These are the three major vendors, or actually the three only vendors that I know of that are selling CO2 liquefaction and collection units that are sized to a craft brewer. That's Dalum, that's us. Hypro, which is a company out of India, and they're a very large producer of all sizes of CO2 collection equipment for brewers. And Earthly Labs, which is a US company, is owned by Chart Industries. This is a schematic that shows basically how a system might fit into your brewery. The green lines from the fermenters represent your collection system. Somehow you got to get the gas from the fermenter to the compressor. So these could be as simple as hoses laying on the floor, or they could be hoses that run from the fermenters and go overhead. It could be hard piped in PVC or stainless steel. It's really just a matter of what you need and how much money you want to spend. The fermenters can operate at different counter pressures, but the minimum counter pressure will be somewhere around 2 to 3 psi because you need that much pressure just to get the gas over to the piping over to the collection unit. At the collection unit, or just before the collection unit, there's what we call a foam trap. This is normally about 2 barrels in capacity, in other words, about 60 gallons or so. Some people use a plastic 55-gallon drum. Other people will prefer a stainless tank that looks a little bit better, perhaps. The purpose of the foam trap is not to actually collect all the foam that could possibly come from the fermenter, but it's basically to stop any liquid that could get into the compressor, because liquids do not compress too well, so it would damage the compressor. After the unit, on the right side, you can see we come out as a condensed liquid out of the unit, and we go into a storage tank. And from the storage tank, when you're ready to use it, we go through a vaporizer. There are 2 different types of tanks. When you're ready to size one, your existing tank is really based on usage and delivery schedule. In other words, how much are you using and how often is your vendor going to deliver it to you? It's not really based on anything else. The new tank, if you go to be self-sufficient, would be sized on usage and collection, and plus a desired reserve. We generally would recommend, if you're going to be independent, the tank would be sized for somewhere between 2 to 4 weeks of storage capacity for you. On the right is shown 2 different styles of tanks. The left one is a stainless steel tank. It's skid mounted. These are very popular because you can move them around. they come from anything from 1 ton size, 2,000 pounds, up to 5 ton size capacity. The tank on the right is a very popular. Also, it's a vertical tank. You probably have if you're leasing right now, you probably have a horizontal tank. But the vertical tanks are very popular because they use less space. And those come up to like 10 or 20 tons of capacity. Next slide. Well, the vaporizer that you select for your system is going to be based on your demand. In other words, how much do you pull at your peak? If you're operating cans in your brewery or packaging cans, it's probably going to cap in while your canner is running. There are 2 types of vaporizers. An ambient one, which is shown on the right next to the white tank there. It's basically finned aluminum tubing. They come in any size, tall, narrow, short, fat, doesn't matter. But basically they take heat from the atmosphere and vaporize the CO2 as you use it. If you're in a warm climate, an ambient one will work fine outside. If you're in a colder climate, you may have to add a little supplemental heating to it. Also, if you're in a cold climate, if you have the space available, you could put this inside your building. It will provide air conditioning during the summer, and during the winter, it'll rely on the building heat, which is normally natural gas, to provide the heat for vaporization. The unit on the left is an electric unit, which if you're leasing a tank, you probably have an electric vaporizer now. They work well, but they're terribly expensive to operate. It's going to take you 1 kilowatt per 25 pounds per hour of capacity. 1 kilowatt is equivalent to probably about 1.5 horsepower motor running. So they are expensive. Eric, you want to take it from here?
Yeah. First off, I'd like to thank Amanda and Andrew and Craft Beer Professionals for having us today. Beer Law Center for presenting this session. Basically, in the phone calls I have is I'm finding 3 types of customers. Those breweries primarily just for sustainable efforts, meaning they have to reduce their carbon footprint, so they have to do something. Then you have the middle of the road. They want to reduce their cost on their CO2, get a good ROI on it, and they realize it's good for the environment. Then you have other breweries that are in a situation where they have to start collecting their own gas and converting it into liquid because 1, it's force majeure, 2, they can't get delivery, 3, their prices have gone from 60 cents a pound to $3.28 a pound. So it just depends on where you're at. Primarily though, the bulk of people are in the 2nd and 3rd tier, and they really want to become self-sufficient and sustainable. Go ahead, Luca. Roadmap to CO2 independence, understanding your usage. What is your end game? Where do you want to be? Ironically, most of the brewers that I talk with, CO2 is more or less a commodity because there's not a big pain point there with a lot of breweries where that they have to monitor it. But if you're going to start working towards CO2 independence, one of the big things that you're going to want to do is you're going to figure out where your CO2 is going. Monitor your day-to-day usage for a period of months. Usually 2 to 3 months is a good thumbnail, especially if you're canning and you do your own keg cleaning in-house. It uses a tremendous amount of CO2. And then the other thing you're going to want to look at is determining your peak usage in pounds per hour. And this is a key number for any system that you look at, because that number right there is going to identify the size system more or less that you're going to need to get you the amount of CO2 that you have to have on a daily basis to become sustainable. So go ahead, Luca. Roadmap. What does your brewing schedule look like? And how firm are you on that? Even being an hour off of beer getting into a fermenter, depending on collection or what have you, can have a big impact on CO2 capture. There's a graph that we'll be showing shortly. So when what you're going to hope that is no matter who you're going to, they're going to be asking you questions on your brewing schedule. So what we do is this graph here, it's fairly simple. It shows one brew a day, 4 days a week, 12 Plato, roughly 5.5 ABV. So this is one fermenter. What we're going to do on the questionnaire and what you should be looking for from, you know, whoever you're getting quotes from is, are they taking into account all of your fermenters? So this peak right here, we could have 8 fermenters on there. And then what it does is it calculates the maximum amount of gas that you're going to be producing per hour. And so that's what our peak collection is. And that's how we're going to size your system. So that's a good question to ask. Is it's like, okay, well, is this unit only going to collect off of one fermenter? Or if I have, you know, 3 of them that are blowing off right now and they're all at the right purity level, can I collect off of all 3? So that's a key question to ask when you're calling around looking for a supplier in a system. Next one. You know, so again, modeling your CO2 schedule, predicting your fermentation peaks, and then the collection in pounds per hour. So what you want is you want something that that's going to be able to collect and produce enough gas to get you to independence, if that's your goal. If you're just looking for, hey, I got to reduce my footprint, you can just go with a smaller system, and you know, whatever it collects, and you know, you can calculate that. But primarily what you're going to want is you're going to want a system that's going to be able to process and produce 70 to 80% of the gas that you're blowing off once it reaches that purity stage. Okay, you can go ahead. Sizing your collection unit, just went over a lot of it. How much of your fermenter gas are you going to want collected? We like to, our calculation is roughly 10 pounds of CO2 per barrel. So where we want to be is, and what you should be looking for is a system that's going to get you 6 to 7 pounds out of that gas converted into liquid. So that's going to be a big one, is just sizing the system to get you the maximum capture in storage. Hit the next one there, Luca. Biggest problem that I have right now is if you're thinking about becoming independent, start the conversation with your current supplier. This seems kind of basic, but you know, if you don't start having those conversations now, you could have everything worked out, and then all of a sudden we get to the end and they're adamant you are not putting that liquid into our storage tank. So then it's kind of back to the drawing board. So what I would do is start having those conversations now, no matter who you're going with, because once it's processed, it's got to go somewhere, and you know, and you got to store it. Another issue is if you want to be independent, you're going to want a larger storage tank. Like John said, you know, 4 weeks in a slow period, 2 weeks in a busy time, because even though you're producing. So it's that ebb and flow to the system, and it's got to go somewhere. So if you only have a 750-pound tank, I mean, most systems are going to fill that pretty readily, and then you're still going to just be blowing off gas. So, you know, have that conversation up front, find out what your options are. Can you buy the tank? Can you purchase the tank? You know, is the supplier you're going to get a quote, can they supply you with a tank or a vaporizer? And make sure that tank is going to be large enough to get you to where you need to be.
Eric, if I could just interject something there.
Sure.
There's a good reason why the gas people do not want you to use their tank. Probably the primary one is when they're filling your tank, they usually are using a balance line back to their tank to balance the pressure back to their truck. So there is vapor going back to their truck as they're moving the liquid to your tank. If your tank is contaminated, it could possibly or potentially contaminate their tank. So that's the reason. I would say that, tell you the truth, any brewery, even big breweries that collects gas, cannot sell it back to the gas supplier. They just don't want to take the risk. So that's really the reason. There are ways around that. They could be venting while you fill instead of equalize. They could be venting out of your tank. But again, then that's wasting CO2 during the filling process.
Right. Now, and there are parts of the country right now where that if they're in a situation where they can't guarantee their supply to you, we are working with those breweries where that we're going to be able to go directly into, that storage tank. So I mean, so there, it's really going to depend on what your lease looks like and the area of the country that you're in. So, next slide. The other one is generally if you're leasing the tank, if you're in the brewery, you're generally leasing the vaporizer from the same supplier. So that's another one. It's like, how big of a vaporizer do I have to have and get that spec'd out? On days that you're canning or bottling, your usage is going to go up in your pounds per hour. Your draw is going to significantly increase. So you're going to want to make sure that you get a vaporizer that's going to meet those needs. And then, is it ambient? If, in Wisconsin, you can get an ambient and put it inside. Electric vaporizer, you can really put those anywhere and it'll work with just about any system. So just deciding on what your needs are is key, and figuring that out up front also. Okay, the roadmap. Wow, this is a big one. A key to this, obviously you got to have the right size equipment for your needs. We'd like to say that there's no brewery too small, and again, when you're talking to potential suppliers, find out how small your brewery can be and what type of flow of gas is needed for the equipment to actually work. The other thing is determine what you need up front. If you're going to be collecting off of multiple fermenters, how do you make that happen? Are there manifolds involved? How do I collect as much gas as I possibly can is the big one. And again, it's going to depend on your goal. Again, if you just want to reduce your footprint, you can go with a smaller system. You collect whatever you can, and that's it. But if you're truly going for independence, you're going to want to make sure that all the equipment and storage tank is sized for that objective. Gosh, it's kind of, when you have a nice car, everybody wants to see it. It's the same thing with this. If you got a great product out there, you're going to want, I'm going to be trying to give you people to talk to, talk to Jan, talk to Paul, speak with people that have these and they're working with them every day. Call them on the phone. Don't just send an email. Figure out what they're trying to say and how they're saying it. A lot of these guys, if they're in tune with what they're doing and they think it's a great piece of equipment, they're going to want to show it to you. So find out if you can get into a brewery that's actually running the collection system and see see what they're doing and how it works into their daily operational standards. How much are you going to have to change in your brewery? In a lot of cases, it's not a lot. It's primarily getting the gas to the system, and then from there, the system more or less takes care of it, in site. And then what's your unanticipated costs? Am I going to have to run new water lines? Do I have to run new glycol lines? Do I have to? Do I need additional tubing to get the gas over to the tank? Those power consumptions. Do I need to put in a new power drop where this is at? So those are all things, and generally, if you got a good team that you're speaking with, they're going to be able to get those answers for you pretty readily. So, but make sure you're calling people and finding out how good and how well that the equipment operates. That's a big one. And then we're going to hand it over to Lenzie now. So thanks for your time, everybody.
All right. Thanks, Eric. Let me also thank the people out there that are joining us for today. So let's jump right in. I know in the beginning, when you're transitioning from what you're doing today about buying CO2 to collecting it and being independent, it can be a little bit challenging. There's a few things we, going to recommend you change, a few things you're going to want to change in order to be the most efficient that you can be. So let's start with the fermenter headspace, that is the volume above the liquid. In order to collect good purity CO2, all of the existing air, once the fermenter is full, that has to be pushed out by the fermentation that's producing active CO2. Now, you would think that since CO2 has a density of roughly 1.5 times that of air, you'd form a blanket, the CO2 would push all of the air out, and pretty quick, the CO2 coming out would be very pure, and you could put that fermenter on collect. Unfortunately, during this process, due to the Brownian movement, which is the molecules of CO2 and the molecules of air, they're mixing together, so that instead of getting a real smooth, sharp transition from air to CO2, we have a mixture. The larger the headspace you have, the more time it takes to do this, and the more mixing you get, meaning you're going to lose a lot of CO2 that's mixed with the air, and you cannot collect that. So the goal is to kind of run with a minimal amount of headspace so that that can be pushed out quickly by the CO2, and we can get that fermenter on CO2 collect. So roughly for a vertical fermenter, 20% volume by volume of headspace is a pretty good starting point. I know for horizontal fermenters or bread box fermenters, the mechanism of pushing it out is a little different, and you might need a little different headspace. But 20% is a good starting number. It's great if you can work your way down lower than that, 18%, even on down lower than that. But if you go too low, that brings us to our second issue, which is one of the big ones that many brewers face. If the headspace is very, very small, then the foam layer that builds up during active fermentation, that also is pushed out in addition to pushing out the CO2. And the foam is a problem. It does not flow through the CO2 collection piping very well. It builds up a lot of back pressure on your fermenter, possibly causing some of the safety devices to lift. And if the foam were to get into the CO2 recovery skid, as John indicated earlier, compressors don't handle foam at all. So the compressor and the whole skid is going into a fault mode. It's going to shut down, and now you won't be collecting any CO2 at all. Now, I know that most recovery systems have a small foam trap, but a foam trap is designed primarily to remove very, very small particles of moisture, not large slugs of foam. So if you're getting a lot of foam coming off your fermenter into your system, it is going to shut down, and that's going to be a major problem. So as part of the brewery operations team, that's going to require some input from the brewery. Now, there's some things we can do. Obviously, if you're running a very low headspace, you need to look at that headspace. If you got a lot of variation in your brew volume and you're just simply putting in one brew or maybe two brews, maybe you are unintentionally minimizing your headspace and you don't really know that. So having a good control over that is good. If the fermentation is so active, maybe you ought to be looking at some of the starting temperatures. If you're cooling in at a certain temperature, maybe if you drop that a degree or two, it'll be a slower fermenter, and then you won't get quite as much foam. The same is true with your yeast pitching. If you're pitching a lot of yeast, of course, it's going to take off really fast, maybe produce a lot of foam and lead to an overfoamer. And similarly with aeration, excess aeration is going to cause the yeast to multiply much faster. You're going to get a vigorous fermentation going on. And again, lots of CO2 may be produced. So those are things that need to be done by the brewery. And of course, the vendor, CO2 skid vendor, can possibly help you a little bit there too. But foamers need to be reduced to either none or a very, very low number, because you can imagine if you're collecting 3 or 4 fermenters on your system and one fermenter starts to foam, that shuts down the entire system, and now you're losing all the CO2 from several fermenters. So this is a serious problem. For ease of getting a fermenter on collect, there needs to be a set of parameters that operators can easily use. If you put the fermenter on collect a little bit too early and it's not ready, then of course there's air going to come out and contaminate the system and shut it down. If you put the fermenter on a little bit late because it's already time to go and you just didn't know it, then all that gas that is ready has been vented and you're losing some of your efficiency. So there are some things that we can look at during the fermentation process to make sure that the timing is very, very easy for the operator. One of the easy things to do is simply use a matter of time. Perhaps 15 hours or 20 hours after fermenter full is the appropriate time. Once you determine that, say, the CO2 is relatively good purity at that time, then it just becomes a matter of being there at that time. Another thing that might be done is temperature. If the temperature has risen a certain number of degrees, then at that point we can assume fermentation is good. All the air has been pushed out and the fermenter can now be put on collect. Same can be done with the gravity. If the Plato or specific gravity, whichever you're using, drops a certain amount, then we would know that fermentation is good. Everything is just fine. The gas is now pure enough to put on collect. I recommend maybe a couple of parameters combined just to be on the safe side. I've used time and temperature as a combination, and when both of them are met, we're relatively sure that the fermenter can go on to collect right at that time. Now, this brings us to process consistency. So if you pick a certain amount of time that the fermenter normally would be ready to put on collect, and your process is not in really good control, then it may not be ready to put on collect. It's either too early or too late. So having good control over your basic brewing and fermentation process is one of the critical things that's necessary for high efficiency CO2 collection. Now, if you don't get them all on collect all the time, then yes, you can be collecting, but you may not be collecting as much as you hope. So some of the things to really look at and have tight control over is the headspace or what you're putting in the fermenter. If your brew size varies all over the map, say it's 12 barrels one time and then the next time it's 14 barrels, pretty quick you're going to have a different amount of headspace than what you think. If you're targeting to have a fermenter full temperature at, say, 60 Fahrenheit, and one day it's 65 and the next day it's 50, then the fermentation rates are going to be much, much different and the fermenter may not be ready. Same is true with yeast pitching. I recommend you use the hemocytometer. You check your yeast pitching. You make sure you've got the right number of cells per mil that your standard is, and you're not under pitching and you're not over pitching, so that your fermentation rate is relatively consistent. And same is true with wort aeration. It's harder to measure aeration, ppm oxygen at fermenter full, but it can be done. If not, use a rotometer, a flow meter or something, but try to have consistency in your entire process. Now, I know that all of us do that in the craft brewing industry for quality. You want consistent process to have good, consistent quality. But I think you'll find that as you get into CO2 recovery and you're sort of pushed into having very, very uniform, consistent processes, you'll find that that's also going to improve your quality because your overall process is going to become more and more consistent and uniform. And finally, managing a CO2 system for recovery does require some input from the operators and from the brewery management team. Now, the skid may operate in automatic, and most of them, I think, have a degree of automation attached to them. But when things go wrong and the system shuts down due to some fault, well, somebody needs to be looking at these things occasionally, whether that's a management person or an operator. Also, someone needs to make some corrective action. If, for example, the glycol temperature that's run into the CO2 recovery skid is too warm, someone needs to look at that and figure out why. So it does require a certain degree of activity in there by the brewery to maintain the high efficiency that we hope you get. Same is true with everything else that's taking place. If you're getting one or two foamers or maybe a few more than you think, someone ought to be looking at that and trying to figure out why and what can we do. And the same is true with sluggish fermenters that aren't fermenting versus the same ones that are fermenting very, very rapidly. And finally, since we're kind of running out of time, if your CO2 recovery system is designed for a certain capacity based on a certain brewing schedule and a certain way of brewing, tank filling, stuff like that, then if you have to deviate it from that, you may find out that you're going to be less efficient. Let me just give you one example. If your brewery is designed to have a CO2 recovery system that collects gas from a two-brew fermenter. You got some two-brew fermenters out there. And one day you see that the brewing schedule is going to put only one brew in that fermenter, and then that's the end of it for that week. You realize that the headspace is tremendously different, and that fermenter is not going to be ready to go on to collect at the normal time. And if someone does put it on collect, there's going to be a big slug of air. The system's going to shut down, and you're going to lose a lot of CO2. So you have to be a little bit active. It's not terribly difficult. I think everyone is got a learning curve there that's going to be relatively fast, but it does require some activity and some monitoring and some attention by the brewery for the system to run very, very efficiently. So at the end of this presentation, feel free to shoot me any questions if you got any. If not, thanks again for joining us and learning about CO2 collection.
Well, I'm here to tell you a bit about my experience with the CO2 collection system from Dalum. We commissioned it in January 2021 as the first brewery in the world with a commercial version of it. And my personal wish with it was actually to be more environmentally sustainable. But of course, there was also an economic reason, which was the high price of CO2. Back in 2021, there was no shortage of CO2 yet, but I was, of course, clapping my hands when the shortage came up and we were self-sustaining. So the technology as such is not super hard to comprehend, but it takes some time to get used to it, to become familiar with it. And like with everything, new car, you have to figure out all the features. And as this was the first commercial plant, there were, of course, some technical issues to start with, childhood diseases, like with any new technology, but they were quickly solved by the constructor. He was very much into helping us because we were fully committed on being CO2 independent. So there was no way back for us. We cut all the lines. So it cost us some nerves to start with, but it accelerated the learning process. So all in all, it was good for us, good for the supplier also. Click, please. So as Lenzie was into, the planning of both brewing and packaging becomes somewhat important once you aim for getting self-sustaining with CO2. For us in particular, it wasn't so important with the collection peaks because for me it was more important to get the plant to run at a good cruising speed. I would say not to always have like full throttle, but I wanted it to be running at like half capacity. It's just like a car engine. If you don't go full throttle, they last longer. And as we brew a lot of non-alcoholic beers, with hardly any CO2 production, it was important to spread out the brews so we could get this good cruising speed into the plant, and also to make the plant run over the weekends. If the plant is running too slow, the electrical energy put into the plant doesn't equal the value of the produced CO2, so that doesn't make sense. So you want to have this nice cruising speed applied, and then there's, of course, the packaging following along. As you have a stock of CO2, you want to use it. If you're low in CO2, of course, then packaging is not on the top of the list. So this demands a bit of planning, particularly in the transition phase. When we installed the plant, this was somewhat important because our stock was low on CO2, but then we built it up, and then life became a lot easier. But also another thing with the CO2 storage tank, which maybe is not something most people would think of, is that the pressure of the headspace in the storage tank. Because if this headspace pressure builds up too much, because there is a natural fall in pressure from the liquefied CO2 to the storage tank, which results in flash gas, which results in headspace pressure. This headspace vaporized CO2 will be led back into the CO2 recovery plant and liquefied again. So this is basically putting energy into something that you had beforehand. So it's also about keeping this head space pressure to a somewhat doable level. So like after a weekend when you were producing a lot of CO2, headspace pressure will be somewhat higher. Then it's a good idea to do some packaging on a Monday. This is experience I've gathered over time. This reduces the electrical energy needed. It's not connected to losses of CO2, but it's just electrical energy you could save. And then there's, of course, the manpower. How do you plan all this? We did it in a way that we had a small handheld oxygen meter, so to determine when is the tank ready to be connected to the CO2 recovery plant. That made our decisions easy. So we were not relying on time, because sometimes fermentation kicks off a bit later than you're used to, for whatever reason. So we were aiming for a level of oxygen below 1%. And so that could happen anytime, basically. But as most craft brewers will know, there's always some random guy in the brewery at all times of day, and even in the weekends. And so this was just a natural part of planning production, to say, hey, is anyone in the brewery in the weekend doing something? Oh, yes, I forgot to do this. I'll do this on a Saturday. And then you would just say, hey, can you please connect this tank, measure and connect? So for us, it really wasn't that big of a problem. And I believe that many craft brewers work in the same way. This can, of course, be automated, but we decided not to do that because it just was too much effort. It was not worth it. There was always someone around. Yeah, click please. So after a quite short while, actually, our CO2 collection skills they improved quite rapid. Yeah, they improved really well. And it just became another part of the brewery routine on the weekly meetings. What should be collected when, and how should we plan the brews? But also, it's important to train the people in the brewery to avoid downtime with the plant. So there are some daily and weekly checks that have to be carried out. They don't take a lot of time. It's a short process in the morning. I normally do that, or someone else. And also the troubleshooting, if there's something wrong, that they understand, how do I troubleshoot with the plant? And also spare parts, of course. There should always be a sufficient supply of like basic spares. This is very good to hand on to the team of brewers, for example, or the packaging people, or whoever you find is whoever comes handy. So it's not just on the back of one person. Yeah, so for us, this worked out quite well. We were a few people who could do this. So also the monitoring of your users of CO2 was a thing we looked into, because in the start and the transition time, we were learning to collect CO2. It wasn't super easy, but we learned fast. And then we thought, okay, but we need to keep our consumption down. So the bit of CO2 we have in store, we need to we don't want to waste it. So it helped us becoming a lot more aware of our CO2 consumption. And the next two slides, click please, illustrate that to some extent. This is the third and fourth quarter of 2021. That means after the childhood diseases and the turbulent first 2 quarters after installation, we got better and better at collecting CO2 and reducing our consumption. The blue columns show this. This is collection, and the orange ones are consumption. And we are actually, in fact, a lot better than the normal Danish benchmark for small to medium-sized breweries with this. And if you go on to the next slide, click please. You see the blue columns. They get like they are taking up more space than the orange columns. So over time, this got better and better and better. And the excess CO2, we decided to sell that beforehand. We knew we would have excess CO2. on gas cylinders and sell it to our draft beer customers. And in this way, it actually really got a super good business case for us. So the break even will be obtained very soon. 4.5 years, it's calculated, and this is very nice. Also considering that we had a bit more costs because we bought the tank from the CO2 supplier, which made things more expensive rather than buying the tank from the CO2 equipment supplier. So, but all in all, really nice and fun to work with, and it makes waking up in the morning a lot more fun. And so then when you're self-sufficient with CO2, this is actually your fourth utility. And this means avoiding downtime is mandatory. Get the machine to know, get the equipment to know, and understand how, like, the refrigeration plant in our case needs to also be in good shape, so to supply a decent temperature glycol to liquefy CO2. So it's all interconnected, and so focus on utilities is important in this case. Yeah, that's it from me. Send me any questions you like. Thank you.
Okay, thank you, Jan. Thank you, everybody. One thing I forgot to mention in my presentation was that, and it's a question, why do we liquefy? Why don't we just compress the gas to store it and reuse it? Well, the liquefaction process eliminates the aromas coming from the fermented ingredients and the sulfur odors from the yeast. Also, and very important, liquefaction allows you to remove the oxygen which is mixed with the incoming gas. As it was mentioned, we recommend starting collecting at, I believe, 0.8% purity. So there is oxygen coming back. In the liquefaction process, from the diagram, you saw that CO2 would condense out at 240 psi and minus 17 F temperature. Oxygen liquefies at a much higher temperature and a much lower pressure. So the oxygen does not come out in the system, but it remains as a gas. So when you compress the CO2 into a liquid, the oxygen remains as a gas. At that point, you can then vent it off. So that's how the CO2 liquefaction units get purities of 99.95 or better from the collected CO2. Another advantage to the collection and putting in a liquid form, it reduces your storage volume by about a factor of 30. So in other words, in the same space, if you're storing liquid versus gas, you'd have to have something like the Hindenburg over your brewery or something if you're storing just the gas. So that's basically the reason breweries go and liquefy the CO2. I don't see any other questions, so I want to thank everybody and thank the people at the Craft Brewing Professionals for giving us the time, and I'd like to thank all of our presenters who did a fantastic job. So thank you. I hope you enjoyed the show.
Thank you also.